about Unit 2, that's talking about thermal energy. First, do you know the meaning of the word thermal? Thermal means heat. So, thermal energy means heat energy. Then, what about the word energy? It's an old term and we heard it before, right? So, what's energy? Energy is the ability to do work. Something that makes me able to do any life activity I need. Like for example, as we talked before, the light energy, it makes me able to see. Sound energy makes me able to hear. Kinetic energy makes me able to move. And electric energy that makes us able to operate the different machines. Okay? Now let's focus about our topic, which is thermal energy. Thermal energy or heat energy is one of the most important type of energies in our daily life. Why? Give reason. Why it's that important? Or in other words, where do we use heat energy in our daily life? Heat energy is used at home in too many ways. Like what? Like number one, warming the house. Like when we use heaters. The electric heaters that we have at home. Number two, in cooking. Nowadays we are using the microwaves, steamers, big electric ovens, and different other machines that help us to cook much more quickly. Something else, water heating. Of course, all of us know the electric kettles or the electric water heaters that we use during shower. What about other uses of heat in our daily life? It's used also in different industries. Industries means manufacturing or making something in factories. Like what industries that based on or depend on heat energy? Like for example, food industries. Like the milk industry, you know, that packed milk that we buy. First, it has to be boiled in huge boilers. Then cool it. Suddenly, then start to pack it in the packs that we buy. Another industry, which is the glass industry. They have to melt it under very high temperature in order to shape it in any shape they want. In the shape of plates, glasses, cups, and much more shapes. Another type of industry is textiles. Do you know the meaning of textiles? Textiles means clothes. How do we use heat in the manufacturing or the industry of textiles? By printing any logo or a sign of brand onto whether a sweatshirt or sweatpant or t-shirt. Something else, sometimes I need to print my picture onto my t-shirt. How can I do that? By using a square iron or rectangular iron and get my t-shirt and put it, then put my picture over it, then start to iron them for a few minutes. After a few minutes, when I take my iron off, I will find my picture printed over the t-shirt that I have. This is what we call the manufacturing or the industry of textiles. After all, that's why we say that heat energy is very useful and essential for our daily life. And now, what's the heat energy? How can I define heat energy? Heat energy is defined as it's a form of energy, a kind of energy that transfers, that moves or flows from high temperature objects to lower temperature objects. What does this mean? Imagine that we are in winter and I was studying at night and it was really cold. My hands were freezing. Then my mom got me a hot cup of chocolate. I held it tightly with my both hands. After a while, I found that my hands became warmer than before. What happened then? What do you think? The coolness of my hands left my hands and passed to the cup, or the hotness of the cup itself who passed to my hands? Actually, what happened is that the hotness of the cup of chocolate who left the cup and passed to my hands, and that's why my hands became warmer after a while. So this means what? This means that heat energy moves or flows from one object to the other direction. The direction or the way in which heat flows from one object to the other. So wherever I have two objects in contact in each other, touching each other, and there's temperature difference between them, at this moment the heat is going to pass or flow from higher temperature object to the lower temperature object. Then, how can I measure the amount of heat inside that object? I can measure the amount of heat inside that object by measuring something that's called temperature. So, temperature, we can define it as it's the degree of hotness or coldness. So, temperature is just a number that refers to the amount of hotness or coldness inside the object. By the way, temperature, it's not only for hot objects, but it's also to measure how cold is my object. How can we measure this temperature? By using a special tool that's called thermometers. So thermometers are tools or devices that use to measure the temperature. Okay, and now let's apply all what we have said. How we are surrounded by too many materials, different materials like wood, plastic, rubber, glass, iron, copper, aluminium, gold, silver, and all other different materials. How do they deal with heat energy? Which materials that allow heat to pass through them and which other materials that do not allow heat to pass through them? How can we discover this? By having a small activity. In this activity, I will get a glass basin. Then I will stick three objects: a plastic ruler, a metal spoon, and a wooden pencil by using clay. Clay is something like plasticine. Then, on each one, I will stick a button, plastic button that we have, like that, what we have in our shirts, okay? Onto each one of them by using wax. What's the wax? It's the material from which we make candles, okay? These candles that melt easily, okay? So again, I have a glass basin. Then I will stick to it three objects: plastic ruler, metal spoon, and a wooden pencil. Onto each one, I will stick a plastic button. How? By using wax. Then I will pour hot water. What will happen to the three buttons sticked onto my three objects? Which button is going to fall down first? The button that's going to fall down first is that which is sticked onto the metal spoon. Why does this happen? This button, which is sticked onto the metal spoon, will fall down when the wax by which it's sticked melts. When does the wax melt? When this wax gain heat or when it gets hot. How does it get hot? When the spoon gain heat and pass it to its top. At this moment, the wax will melt and my button is going to fall down, which means that my metal spoon is a good conductor of heat. It allows the heat to pass through it from one place to the other. Then, what about the other two buttons who stick onto the ruler and my wooden pencil? They will not fall down. Why? Because the wax by which they are stick didn't melt. Why it didn't melt? Because it didn't gain heat. It didn't get hot. Because my plastic ruler and my wooden pencil, when they gain heat, they will not pass it to their tops. So wax will not melt and buttons will not fall down. Which means what? Which means that my plastic ruler and my wooden pencil are bad conductors of heat. They do not let or they do not allow heat to pass through them from one place to the other. That's why we are going to classify materials, or we can divide them according to the heat conductivity. What does this mean, heat conductivity? Heat conductivity means the ability to pass heat from one point to the other into two groups. The first group is called like liquids. Most of liquids are bad conductors of heat. And like air, the air that we breathe and it surrounds us everywhere is a bad conductor of heat, or it's a heat insulators. They do not allow heat to pass through them. What about the other group? The other group is called heat conductors. Those that we called before good conductors of heat. Those are the group of materials that allow heat to pass through them. So they pass the heat from one point to the other. Like what? Of course, like iron, like copper, and aluminium, and silver, and gold, and mercury, the only liquid which is a good conductor of heat. All other liquids are heat insulators or bad conductors of heat. Let me here ask you a question. What do you think? Do they all are the same in conducting or in passing heat? Do all heat conductors conduct or pass heat with the same speed? Are they all the same? Actually, no. Heat conductors, in between them, they are different in the speed of passing heat. How can we prove this? We are going to prove this now by doing a very small experiment. Here in our experiment, I will get 3 rods. Rods means sticks. One of them is made of iron, and the other one is made of copper, and the last one is made of aluminium. I will stick an office pen, it's a metal pen, onto each one by using also wax. Then I will put the tips of my 3 rods over the frame of a lighted up candle. After a few seconds, what will happen to the 3 office pens? What do you think? Actually, the 3 office pens are going to fall down all. Why? Because all of them are good conductors of heat, whether iron, copper, or aluminium. All of them are going to pass heat until it reaches to the wax. Then wax is going to melt, and the 3 office pens are going to fall down eventually. But the question is, which office pen is going to fall down first? Actually, the office pen which is stick onto the copper rod is going to fall down first, followed by the one which is stick onto the aluminium, then finally the one who stick onto the iron rod or stick. What does this mean? This means that copper conducts or pass heat faster than aluminium, and aluminium conducts or pass heat faster than iron. So after all of them are good conductors of heat, all of them are heat conductors, all of them pass the heat through them from one place to the other, but in different speeds. So they are different in the speed of passing heat through them. So I have here copper, who's the fastest element in conducting heat, then it's followed by aluminium, followed by iron. Here we have a very important scientific fact that says metals expand by heating and contract by cooling. What does this mean? First, metals. If you remember in Junior 4, we have classified elements found around us into 2 main groups. The first group is called metals, and the other group is called non-metals. And each group has its own properties. The group of metals, those are elements which are good conductors of heat, good conductors of electricity, have luster, shiny elements, and they are malleable and ductile, and they have high melting point. Those are the properties for any element that belongs to the group of metals. So, any metal like iron, copper, aluminium, silver, gold, expand by heating. What's meant by expand? Expand means enlarge or get bigger. So expand means get bigger. So any element, any metal, when I heat it, when it gets hot, it expands, it gets larger, it enlarges or increases in size. But if I cool it down or decrease its temperature, it will contract. What's meant by contract? Shrink. Or what? Or get smaller. So again, metals, the group of elements which has all of the properties that we just said. When I heat them up or when they get hot, they get bigger or they expand. But if I cool them down, they contract or shrink. Now, after we have learned about the difference between good conductors of heat and the bad conductors of heat, and we said that bad conductors of heat, they never let heat to pass through them, while good conductors of heat or heat conductors, they allow or let heat to pass through them. How can I get benefit out of this scientific fact for my daily life? How can I use this to be much more better than before? Here we have the most important usage of good and bad conductors of heat, the materials themselves that we talked about them before. Here for the good conductors of heat, if you remember, good conductors of heat were like what? Iron, copper, aluminium, and something that's called stainless steel. Those are the materials or the names of elements that belong to the group of good conductors of heat. Where do I use them in my daily life? For example, in the making of cooking pots in which I cook. So here I need to use something that's a good conductor of heat, so the heat can pass through my cooking pot easily to cook my food quickly. Something else, the electric kettles in which we boil water, or generally in the house, for example, to make the electric wires and much so on. Something else in factories, to make the machines. Most of the machines are made of iron, also the electric wires, and too many other things. What about the bad conductors of heat, such as what you remember? Like wood, like plastic, like rubber, like wool, by the way, that we wear in winter. All of these are bad conductors of heat. They never let heat to pass through them. So how can I use them? For example, the handles of pots. In order to not burn my hands, the hot will be very hot while it's already on the flame. So its handles has to be a bad conductor of heat. So when I hold it, I will never burn my hand. Based on the same idea, the handles of the electric kettles and the hands of the iron by which we iron our clothes. Finally, the heavy blankets. This is what we cover with the winter. And the woolen clothes, just like pullovers and coats. Why do we make them from wool especially? Because this wool is a bad conductor of heat material. So when my body is very, very warm, this heat, when it starts to pass from my body to the surrounding cold weather, due to the heat direction, if you remember that we called about it in the first part. Heat passes from high temperature object to the lower temperature object. So in winter, when the surrounding air is very cold and my body is very warm, heat tends to leave my body to the outside air. So if I wear something that's made of wool, or if I'm covered with something that's made of wool also, the heat will start to pass through my body outside. This material will never let it pass. So this will keep my body warm for a very long time. Thank you so much.